Hi there, good to have you here. In this video I'm going to review the brand new 3-in-1 Tooltop ET829. This is a device that has 80 MHz oscilloscope, 6000 counts multimeter and a 5 MHz signal generator, and is the first Tooltop collaboration with the channel. I have in my plan to do a review series of portable oscilloscopes under 200 euros or around 220 to 30 dollars, and this device fits in that category. I spent my weekend trying around with the ET829 and already have an opinion about it, but that is to be revealed ahead in this video. For now, the usual disclaimer where I tell you that I received this device for review from Tooltop without any costs to me, but I didn't receive any payment for making this review. Even so, it was nice for Tooltop to send this product for review, so a big thanks for them, and also for all the channel viewers that help me to maintain the channel by using the affiliate links in the description and the affiliate links in the screen. You'll pay the same for your purchases, but by using these links you are helping me with the channel. So to you all, thank you for your help, it's really appreciated. And now I will show you all about the ET829, and we'll be back in the end for the conclusion. So let's do this. Okay, as usual, let's start by seeing what is delivered and the unboxing. I already take this out of the delivery box. It doesn't make sense to waste time with that. So the box, it's an unbranded box that you have here. No brand is announced. You only have this Tooltop ET829. This is pretty usual in the Chinese products, so they can rebrand without having to do more boxes. As you can see, we have here some screens of function, and also from this side the multimeter. Okay, so it says it has a 2000 milliamps hour rechargeable battery. Pretty cool. In the back you have some specs: 80 MHz, 200 megasamples per second, 2 channels. You can take the probe up to 100 times, yeah, trigger mode, blah blah, and some multimeter specs also in here. So we have voltage, current, resistance, frequency, AC voltage, AC current, capacitance, and continuity. Pretty cool. Let's move on and see what comes inside the box. We have the normal user manual. I think this is only English. Yeah, it seems to be in English. It's only black and white, but yeah, pretty well organized it seems. We have, so let's start with the cables. We have a USB. This is micro USB. Yeah, this is a micro USB, it's not USB Type-C. Weird. And we have also alligator to BNC cable and a set of probes. Let me take it out. Well, are those cheap probes? Yeah, not very flexible, but even so, They seem nice. Yeah. Okay. And what else? Obviously we have the unit, and I should guess this is the P, it doesn't say, but this is the P6100 100 megahertz. Yeah, I'm almost sure of that. So yeah, that's it, what was delivered in the box. Let's see what we have in here. Okay, this is heavy, comes in this plastic bag, and it has this bag, this cover to take it to store it while not working. Yeah, this is nice. It seems impermeable. I don't know if it is. Okay, this is big. Well, this is in the same size of the Owen or the Handtech. They also have similar devices, so nothing special there. In terms of design and for first impressions, it seems easy to work. This nice rubber finish in the sides give a really good grip to hold the device in your hand. It will not allow you to slip. You have all the keys with a rubber finishing. Yeah. Well, while I have to see it while working, but the press, it doesn't seem to be a very. Maybe this is very, yeah, you don't feel the click. Maybe this is just touch system. Yeah, it seems that we have a very nice holder in the back. On the top we have three, yeah, channel 1, channel 2 and generator output. Nothing in the bottom, and we still have this, let me see, we still have this connection here on the side. I think this is a USB Type-C. Let me see. Yeah, this is USB Type-C. I have here the plug to connect it, but the cable that is delivered, it's micro USB. Let me check again. Where did I put that damn cable? Ah, here it is. I'm almost sure this is not, yeah, this is USB, micro USB. So I don't know what is going on here. This is not for this device for sure. Okay, so that's what we have for first impressions. I don't see anything else here worth mentioning. The normal multimeter sockets. Okay, let's power this on and see what we have. So let's start this. Yeah, it takes... okay, you have to do a long press to start this up. Okay, very nice numbers. They are big. You can see here on the screen also identification where you have to connect the cables, so, or the leads. Right now you have the COM1 and the voltage. Yeah, you have the battery indicator here, and those two sockets probably are those two. So in terms of screen, you have the auto here with the range selected. We are now in voltage, millivoltage to be more correct. And this seems to be, yeah, DC voltage. The screen has these four options that, for what I see, must be controlled by the function keys like this. Yeah, right, AC, and we have the change here for AC symbol, and Hertz, and last Dutty cycle. This is to identify the Dutty cycle of a generated signal. Okay, so the next one is ohms. I think this is diodes. Yeah, we have the continuity. It says continuation, but it's the continuity. And the last one should be capacitance. Yeah, Okay. You have also the current, and if you notice, look in the top, as soon as I change to current, it will tell you that you should use these two sockets, milliamps and COM, and probably if you change this to, this is DC current, AC but with milliamps, DC milliamps current, AC milliamps current, it is staying the same. But for sure, if you change this to DC amps, yeah, now you have to use the common and the 10 amps with fuse also. Well, this one has fuse also. So this is pretty neat to show you this information. You have also the information on the side, and AC amps, this is alternate. Okay. So in terms of multimeter, seems very easy to work. I will test all of this in a bit. Let's see what the utility shows us. We have the beep. We have, and the beep is disabled. Let's see. On. Okay, I think I will disable the beep again because it's quite annoying. Yeah. So in terms, you have also the backlight. To be honest, yeah, I see it change here. I don't know if you guys see this better in 5, but I will leave it like this. And the power off. Okay. If you want to power off automatically in 15 minutes, 30 minutes, 60 minutes, or never. Okay. So this is a nice one also. And in the utility, that's all we have. We have the trigger and some other function. Let's see if this do something here. It says relative to something. Maybe I have to see in the manual because this one I didn't get it. And in the bottom we have the auto, and it takes, right now it's in manual mode. You can change the range. You have here the range. But how do we put it again in auto? Okay, let's see if like this. Okay, and if I take it like this, okay, now it's not auto. Yeah, you have to get out of the menu to activate auto again, for what I understand. Let's see menu, what we have. We have data and calibration. So no auto here. Take menu out. Yeah. Pressing auto several times, it will change the range of the, manually, it will change the range of the value. But to activate again the auto, you have to leave the mode where you are. So that's, yeah, that's not perfect. Okay, you have also, and I saw the menu key already, you have the save and the hold. And the hold, it's pretty neat. It has here a value. So I believe that while you are on hold, it's measuring, yeah, it's moving. It's measuring the, how you say, the current value that it's on the leads. So pretty nice also. We will test this in a bit. And yeah, that's it. We have, for multimeter, I think that we have everything. We have channel 1. Okay, activate the multimeter, or channel 2 also activate the multimeter. Very nice. And we have in the corner here the AWG, or the arbitrary wave generator. And I'm pretty sure this is not arbitrary. You cannot create your own waveforms, I think. We will test this more ahead, but I'm pretty sure that you should not be able to create your own arbitrary waveforms. I don't know why this is not being able to change. Yeah, let's change this to, I don't know, 3 volts VPP. enter. Yeah, this is not working in any of the options. Well, but why? It's something to do with this. Okay, we will check this out more ahead in the video. Let's just see what we have here on the oscilloscope. So I think this is the trigger. Well, I don't think, I am pretty sure that this should be the trigger. So let's try, yeah, to the left or to the right you change the time division, up and down you change the amplitude. So nothing new here, it's also all the same always. We have here the trigger modes. This is the offset of the trigger, the slope, and yeah, the channel. Let's power channel 2 also. Yeah, and you have here the information of channel 1 or channel 2. How do we change between channels? Like this? Yeah, it seems. For each channel you have the DC or AC coupling. Let's see it. Yeah, and ground. You have also ground coupling. So you have the probe 1, 10 or 100 times, and the bandwidth limit on or off. I will take this off. And this is the position, vertical reset and horizontal reset. Where did it go? Okay, like this. Position on or off. And with position on or off, you are able to move this line instead of moving only the cursor. And I'm pretty sure if I use the right and left, yeah, we will move in the buffer. So we have also a vertical reset and a horizontal reset. Okay, and the auto. It's auto setting. Well, we don't have a signal, so it took a little more time. Yeah, so it seems okay. Let's start testing this and see what we can do with this. Okay, so I will start by showing you the oscilloscope function. For that, I will connect this to my function generator. Let me just connect here to channel 1. Yeah, I will start by channel 2 because channel 1 has this weird color. Red, it's not a very nice color to use in here. It's not very readable. I don't know what is going on also with my cable. Yeah, like this. So let's activate channel 2 and deactivate channel 1. Yeah, I think this is better for seeing the signal. I will start my signal generator. Yeah, it's already receiving signal, and let's do an auto. Okay, so we can see on the screen that we have -8 millivolts trigger offset. Currently channel 2 it's with an amplitude of 200 millivolts per square, and we have also a time sync of 15 nanoseconds, because this is small letters. Sometimes I have a little bit difficulty to read it, sorry. So we have here the signal. We have -8.01 millivolts trigger offset, the rising slope, trigger auto, this is the battery. Channel 2, it's right now with the amplitude per division of 200 millivolts, and the time division, the horizontal time division, it's 50 nanoseconds. So the signal seems pretty accurate. Okay, so let's try to increase the time division. Yeah. Okay, 1 megahertz signal. This jumps a lot. It will be nice if we can increase this in smaller, like this doubled, 100 megahertz to 200, sorry, 100 and 200 millivolts. So it kind of doubles the signal and the difference and passes for 500. It will be nice if we can do it in smaller portions. So yeah, 1 megahertz seems okay. So you control the amplitudes up and down and the time division using the keys to left and right. If you want to move the line in the screen, you just need to activate channel 1. Also, you have here the DC coupling and the probe that you can change, and F4 show you more options. You have position, you have to activate the position, and then you will be able to move the line offset. I'm moving line 1, that's not what I wanted. Let me take this out of the screen, bandwidth limit off, and position on. Okay, so in this one, I will be able to move the line across the screen, the offset. Okay, let me bring back. It takes a while. It doesn't have the speed function for that. And if you have to take the position off again to be able to use the offset and amplitude again. So auto, let's see how it goes. Yeah. Another thing in the position, I think I already mentioned it at first, but let's see it. I will activate it again. Yeah, if you use position to the right or to the left while position is on and you move to the right or to the left, what happens is that you will move in the buffer, as you can see here. So yeah, let's increase the time division. Like this, you have a bigger buffer occupation. It will cover a bigger area. Let's press trigger. Okay, pressing trigger, you have trigger on channel 2. You can change it. Yeah, channel 1 and channel 2. And if you change, look here on the top, it will say in which channel is the trigger. You have the slope rising or falling, and you change here also, and obviously the signal. The trigger mode, auto, single, and normal. Let's keep it in auto. And level reset. So while in trigger modes, you can move the trigger manually. As you can see, it's moving, and you see here the offset of the trigger changing. Yeah. And basically this is it on trigger. And you have menu. Oh, in menu we have the waveform option. Okay, we will be able to save and to retrieve the waveform if I want to use this one. Okay, this is a previously saved waveform on channel 1. How I get back F1. And is it possible to delete this? It should be, but okay, erase all. And if I want to erase only one, okay, let's take it out. So basically this one, let me take the channel 2 off. This one, save success. Menu, waveform. Okay, so PPP 1 volt, 10 megahertz. Pretty cool. Okay, so in terms of keys, I don't think that we have much more to see. We have vertical reset and horizontal reset. Utility, we already saw it. And menu, menu had a few options. Okay, so in terms of volts, let's see what we have. We have VPP, and I want also VRMS. In time, we have frequency, yeah. And for me that's it. And invert channel, no, we don't want to invert. We have IE cursors for channel 1, okay. And we have also the option to calibrate that I will not use right now. So let's take menu out of the screen. I don't see cursors anywhere. Yeah, where is it? It says here that we have IE cursors. on channel, sorry, I'm on channel 2. My bad. Okay. Even so, where are the cursors? Am I missing something? I'm on channel 2. I want cursors. I don't know what is that. Should have some information here on the screen with the cursors, but I will read on the manual and I will see if we have the cursors function or not. Well, right now, maybe since we have this information on the screen, maybe it's time to test the bandwidth. My function generator is set to 10 megahertz right now, 1 volt VPP, offset 0 and phase 0. As you can see in here, the VPP it's 1 volt. It's what the function generator is outputting. Let's see how much we can take this before the VPP drops below 720, 14, 10 millivolts. Okay, so let's start this, the test bandwidth test. For that, let's move to 20 megahertz. Okay, we are at 40 megahertz right now. It's half of the bandwidth, and for that, well, it seems that I crashed the oscilloscope. It's not responding to anything. Yeah, I think it's crashed. Nothing happens. Let's power this down and try again. Okay, it's booting. Let's go to channel 2 again. We should have already here the signal. And I have to go activate again the volts, VPP, and also the frequency. So we have on the screen the frequency. I think that's all. Okay, so as you can see, we have 40 megahertz, 970, 80 millivolts. So let's keep increasing. 50 megahertz, 60 megahertz. It still is up of the minus 3B voltage. Okay, so we are at 70 megahertz. Let's increase here the signal a bit. And 70 megahertz, it's giving me 620. That's weird, because I tested this before doing the video. Let's change the channel. Activating channel 1. Let's take this out. And for channel 1, bandwidth limit off. Okay, let's do auto setting. Okay, so right now it's very hard to see, but we have here for 70 megahertz about 70, 20, 12 to 20. It oscillates a bit, but this is still over the 740 to 20. Yeah, it's there. So right now we are at 17 megahertz, and let's try 80 megahertz. So in 80 megahertz, as you can see, it dropped a lot. So yeah, I still think that this will be a 70 megahertz oscilloscope, and that's not bad. That's not bad, considering all the products that we see from China that have half of the bandwidth that normally they declare. So right now this is 7 megahertz, so 7 out of 8. It's, well, it's not the ideal. The ideal will be to have it in 80 megahertz, but even so, okay, we can see that over 72, 70, yeah, 725, something like that. Let's take it to 100 megahertz to see what happens. Right now we are at 90, and this is 100 megahertz, and nothing we can do with this. You see the signal jumping all over the place. You have here 40 millivolts instead of 700 and something. So yeah, definitely, but this is sold as a 80 megahertz, so if you goes there we will be happy. And yeah, in terms of oscilloscope, even with this little difference, I'm happy. It's easy to work. We can save the image, so DSO. In terms of menu, I don't see any special functions here like XY mode or cursors. It says here IE cursor, but to be honest, I was not able to see any cursors on channel 2. Okay, in terms of oscilloscope, I don't have much more to show you. Let's continue with the multimeter and the signal generator. Okay, to show you the function generator operation, I have already my MIG-SIG here on the side. The function generator, to activate, you just press here HWG. This is not an arbitrary waveform generator, no way. If you are in any other function, like the multimeter or something like that, you just press HWG button and you will come to this menu. Again, as I was saying, this is not an arbitrary waveform generator. This is a very basic function generator. In terms of available waveforms, you have, let me show you here, the square wave, the ramp, and the sine wave. I don't know why I am not able to edit the Dutty cycle. I don't know if I have anything. Let me see in the menu. I don't have any option in the menu, or auto or whatever. No options, no additional options. So I'm not able to edit this in any of the options that should be available, like the square wave, to edit the Dutty cycle. So looks okay here in the screen. But I'm not able to change the Dutty cycle. Don't know why. So again, we have square, ramp, and sine wave. You can change the frequency pressing F2 and choosing what else you have here, the greatness or the range, and obviously you have in here the number selector, like 2K right now, and also you have here you can select the amplitude by using this F3 menu and navigating the options. Or let me show you, you can use the up and down. As you can see, it's changing in here as I change the voltage on the signal function generator. It changes in there. Also, you can change the time base using the right and left keys. As you can see, I'm changing the time base of the signal. You should be able to do something similar here using, for example, the square wave, but I don't know why it's not being able to do that. It's not even activating this function. Really, don't understand why. Okay, but other than that, it works great. You have here the time selection. So yeah, let me just connect this, and you can use this on the same time on your own oscilloscope. This is right now with the sine wave. Let's pass it to channel 2, do auto, and I will take the channel 1 off the screen, so we have the trigger on channel 2. And here it is. You have the sine wave with everything that was defined. I don't remember what was the values, but what was defined on the function generator. So yeah, in terms of signal generator, pretty simple, but it will do the job. Okay, moving on to multimeter, and I will do an exhaustive test on the multimeter. Let's move on. Okay, so this has the multimeter function, so I will test this a little bit. So I have my DC voltage calibrated already here. Let's start by testing it with 1 volt. So Siglent is 2 digits off, and here is 3 digits off. But we notice that Siglent is 3 digits, it's 2 digits, but it's on the less significant digits. So 2 volts. Okay, still the 2 digits. We have here a little more difference. Okay, 6 digits. And yep, 9 digits to 3 volts. This is spot on, basically. Okay, 3.989. We are measuring 4 volts, and we have here 3.998. 5 volts, 499.85. Okay, 499. And in here we have 490.87. Okay, in terms of volts, 6 volts, 7 volts, okay, 8 volts, 3 digits out, this is almost there, 9 volts, and yeah, that's it. Let's move on this to millivolts range. So we have 100 millivolts, basically spot on almost. We have a little difference in here. Okay, 200 millivolts, 300 millivolts, always the last significant digit a bit off. In here we have, yeah, we have a little difference. 300, 400 millivolts, 500, 500, the Siglent still spot on. We have 2 digits, 2 major digits out here. Sorry, this was 500 millivolts, now 600, still 2 digits out. This is spot on. 700, 800, and well, 800 here, it's spot on, really spot on to the 0. And here we have 3 digits, three digits difference, 900, and that's it. Okay, let's move on to a different. Okay, 10 millivolts, 20, 30, 40, 50, 60, still missing some digits, 70, 80, 90, and okay, let's start in a different range again. 1 millivolt, spot on the Siglent. It's missing here some digits. 2 millivolts, 3, 4, 5, 6, 7, 8, 9, and yeah, basically that's it. And if I go to the microvolts, it will not be possible to detect here anything. Yeah, it will be okay in this section, but in here it's not possible to detect anything. It's out of range. Yeah, so this is just a curiosity. I'm pretty happy with this multimeter. Has 2 years and it still is spot on. I never done anything to calibrate this, so yeah. Okay, finally I will take a look only in my voltage my millivolts board, because all my multimeters were tested with it, so we have a point of reference also. And yeah, let's see how it handles the millivolt boards. Well, since this board was made on PCBWay, the channel sponsor, let's hear something about the PCBWay services. Now is the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. Now that you know where to build a board like this, let's start testing, and we will start with 10 millivolts. Okay, in terms of 10 millivolts, regarding this board, we have 10.4, 10.5 output here on the ET829 and 10.59, 60, 59 on Siglant. So pretty near, pretty near really. Okay, moving on to 25 millivolts. 25 millivolts, we have 24.9 on the Tooltop and 25.22 on the Siglant. Again, pretty near. Let's move on to 50 millivolts, and with 50 millivolts we have 49.8 on Tooltop and 50.17 on the Siglant. A little difference between the both. We have here 100 millivolts and we have there 197, and in here 99.5. So 4 millivolts difference. Okay, we have 248.6 here, 249.48 in the other one, the Siglant. Okay, still good. 500 millivolts, and we have 500.3 here, 501.19 there, and this one is over 500. So I still believe that Siglant is the accurate, because the values that I have here is also over 500. Now we are on the 1 volt range, and the output from this is 98.6 on Tooltop, 98.95 on Siglant. Very near on 1 volt, 2.5 volts, 2.484 and 2.4906. Okay, and this one is that one. I still use this old board. I have a lot of new boards here to correct it with the diagram correct, but I still use this old board because this is the one that not every multimeter is able to detect here the 5 volts or 4.35, and this one is, it's 4.37 and also nearly the same on the Siglant. So nice work with the millivolts reference board. And okay, let's move on. I will now see how this handles the milliamps. Okay, so in terms of current, I'm gonna test only milliamps. I have here my FNICSI SG004A. So let's start by outputting 1 milliamp to see how it handles. So it's 1 digit over, nothing serious. Let's move on. This can output a maximum of 24 milliamps. So 2 milliamps, okay. 3 milliamps, spot on. 4, 5, 6, 7. Yeah, 7, it's 1 over. Nothing serious, really. 8. 9, spot on. Let's move on. 11, 12. Yeah, pretty accurate in terms of current. Okay, 16, 17, 18, 19, and 20. 20 is 3 digits over. Yeah, but still okay. 21, yeah, right now it's a bit over. And 24, it's a limit. So 24 milliamps, it passes 4 digits. Okay, but for me it's okay, really. I don't see any problem. So in terms of current, that's what I'm gonna do for testing. Now I will test other functions like the frequency diode and so on. Let's move on. Okay, before testing the resistance and the capacitance, let's see how this reacts in continuity. Okay, it seems very fast to give the sound, a little slow to show you the resistance. Yeah, not even, it takes almost 1 second to show you the values, but in terms of detecting, yeah, it's pretty fast to beep, but the values on the screen takes a while to update. Okay, in terms of resistance and capacitance, I will use this reference board. The manufacturer had some values registered when the board was tested, so I will use these values as reference to test the accuracy of the Tooltop ET829. So let's start. The first value is 10 ohms, and in terms of resistance it's 10.1, so it's okay. The second is 100.23. Let's see if I can find this. 99.9. So the next one is 0.998 kilo ohms, and the reference value is 1.003. Okay, this one is 9.995K. Let's see what we get here. 9.97. Yeah, 2 digits out. And this one is 100.06K. And we have 99.8. So let's move on to capacitance. Okay, in terms of capacitance, we have here 102 picofarads. So this one says 0.092 nanofarads. So moving on to 1.02 nanofarads. Yeah, not far. 1.3. This is 10.4 nanofarads. 10.34. Okay, also good. 98.7. 98.1. Okay, a bit below. And this one is 929 nanofarads. Okay, this is a bit below. This one is really a bit below. So, okay. Let's move on to 10 microfarads. 10.56. Okay, near. Let's go back to the 929. I will give it time to charge. Yeah, it will not go much over this. 894, and the value on the board it's 929. This one is the one that has a bigger difference. Yeah, I changed the leads, but still bigger difference. So it's not perfect, but not bad at all. Not bad at all. Okay, so I think that I still miss the frequency and Dutty cycle. Let me just connect here my function generator. We will be able to test both with the function generator. Let me just connect here. Okay, and also this one. So in terms of frequency, let me put here. Okay, in this F3 option, in terms of frequency, and I think that you can see on the screen. Let me show you. We are with 5 kilohertz in this line, 1 volt peak to peak. Let's increase this until 10 kilohertz. That I think it's the maximum. Okay, so right now it's 7.5. Let me see on the manual what is the maximum frequency that it can handle. So it says here that it can go up to 9.99 megahertz, from 10 hertz to 9.99 megahertz, so 10 megahertz. Maybe I'm doing something wrong, but I don't think that is being able to go there. Let's put something like 10 megahertz. Okay. Let me put the square wave. So 10 megahertz square wave. Not even able to detect. 9 megahertz square wave. Sine wave. Nope. Not even here. Okay. So yeah, the frequency it's not being able to detect in the range of megahertz. Let's move this to 5 kilohertz. Okay, 5 kilohertz is able to go 5, 6, 7, 8 kilohertz. It's still good. 9 kilohertz, 10 kilohertz. Okay. 11, but after 10 kilohertz, I think this is a typo. This cannot be megahertz. It will not be able, it doesn't even detect. So, yeah, I'm increasing to 15 kilohertz. And what happens is this start to diminish. I don't know. Yeah, it goes berserk totally. This is 20 kilohertz. So the maximum of this is 10 kilohertz in terms of frequency measuring. 10 kilohertz, it will give you 999. So yeah. It's basically what we have here, but the range is wrong. Okay, so in terms of frequency, you can go up to 10 kilohertz. Let's see in Dutty cycle if we can detect the Dutty cycle. So right now it says it has a Dutty cycle of 53%, 54 almost. Let's pass this to a square wave. Yeah, still there. And okay, right now I have here the Dutty cycle in this square wave of 20%. Let me check. 30%. It's not right. Let me see the Dutty cycle. So Dutty cycle from the function generator is 30%. Let me take this to 50%. Okay, in 50% it seems okay. Let's put it 10%. It does not detect. Uh-oh. Wah, 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 wah. 20? 30%. In 30% it's when it starts the testing, and it says it has 20%. So 40, okay, pretty near. 50, 60, it passes. 70, 80, and 90, it's already all screwed up. And yeah, let me take this to 99%. I don't know if it is the digits. It does not have any more digits to decimal to show or something like that, but even so. So basically on 70% we have 88%. So this is quite screwed up. It's not working properly. Okay, so but this is basically tested. You have an idea of the quality of this. I don't think this is a bad device, for the contrary. Yeah, it has some issues, but for a portable device, okay, not bad. But I still want to show you some features like the hold function. So for the hold function, I will connect here the cables again to my function reference to show you something. Okay, let's start this, and DC voltage. Okay, we already saw that it has 249, but if you press the hold function, as you can see, we have here another voltage. This is freeze, and we have here a message saying it's on hold, and we have a value in there. If I change the voltage, you can see that this one is freeze, but you have the current value that is being measured on that small box, and that is a really cool idea. As you can see right now, it says it's overload because the range, while it's on this froze position, the range will not change. So if I do a run again, okay, and auto, right now it detects 7048. If I do a hold again, 10 volts shouldn't be a problem. Yeah, we have here the 10 volts. So yeah, this is a pretty cool feature because you can hold the value and you continues to show in here. Another feature that I didn't show, let me unhold this, is that you can save the values. I press save, as you can see here, save, and after you can go to data, menu data, and you have here the save values that you have. For example, if you are testing something and you want to save different values through the steps you make, and this will allow you to record that values. It says if it is millivolts or volts or whatever, and it will save you the values in here. So another pretty cool function that you have in this device. So I think that's it. I think I already show you also how to use the manual. Right now it's in auto, but if you press auto again, it will start the manual range for this. Okay, so you will be able to change the range of the measure by pressing auto. I have to say that after all the ranges passed, this should be able to go back to auto. It's not. So the only way I found to get the auto again, it's moving to another function and going back to where I was previously, and then I have the auto. If you guys know how to do the auto again, how to enable the auto again, just leave in the comments. Okay, so let's move on and do the conclusion. Let's wrap this up. For 128 euros or around $138, this is not a bad option to have in your workbench. It is 3-in-1. It will give you a fairly accurate 80 MHz oscilloscope, a nice 6000 counts multimeter, and a 5 MHz signal generator or function generator. So all considered, it's not a bad investment. But let's slice this by topics. First, the design. It is modern, and the rubber finishing on the sides give it a nice grip while using it. It will be great if you have it also around the corners for extra protection. The rubber keys are nice, but sometimes they are hard to work. You kinda have to press it a bit more to work, but most of the time they will work okay. It is a cool detail showing on the screen where you should connect your leads when measuring voltage current in milliamps or amps. You should know that, but it's nice to see that info as a reminder. In terms of multimeter, mine seems not to be 100% accurate, but even so, it is within the acceptable values, and I saw other review videos where the multimeter was almost spot on. So I give this one a free pass and accept that my unit, the unit I received, might need a small tune-up. Even so, it has a lot of functions, and the hold function with the continuous voltage monitoring in the screen is a nice touch. The rest of the measurements function were okay too, so for me it is a pass. In the oscilloscope, the red is a bad choice for the channel color. Blue or green will be much easier to read, but other than that, it is okay. Pretty intuitive, and the announced bandwidth is almost there. It went up to 70 MHz with VPP over the -3 dB, so even with this small glitch in the metrics of not being really 80 MHz, at least in the way I tested, and I'm open for corrections, it still is nice, considering this is a portable oscilloscope. The 5 MHz signal generator or function generator is pretty basic, but gives you the main waveforms to test and will allow you to customize most of the parameters, like for example the amplitude, where I know some desktop oscilloscopes that will not allow you to do that. The overall experience was positive. If it is the best portable unit, maybe not, but for the price range it is a really nice effort, and it will not let you down with the investment you make. So I leave in the description the link for this device. Who knows, maybe you are on the market for a unit like this. But remember, even if you are not and want to buy something else, using the links on the screen will help the channel anyway. Again, thank you for your support. Thank you for being with me, and I hope to see you in my next video regarding this one. If you haven't already, please subscribe, slap that like button and hit that bell so you can be notified whenever I upload a new video. That's it for today. Stay safe.